Hi students, I'm your Komali Mam. In this session, I'm going to teach you NCERT in-text and exercise questions from solid state chapter. See, one by one chapter I teach you. First, I'm going to start with a solid state from class 12. Let us begin with question number 1. In a simple way, I'll teach you. These sessions will help you to solve the questions in an easy manner. Once you listen, it is very easy for you to recollect. Let us see the first question. Why are solids rigid? The constituent particles in solids have fixed position. Means solid, if you see this pen, it is rigid. It can't move from its place. The particles position are fixed. Only it can move. Solid structure, normal solid structures, they may move in its position. So can oscillate in their mean positions. That's why they are rigid in nature. They are not flexible. What is the meaning? Why are solids rigid? Because their positions are fixed and they can't move from their position. Only they can oscillate from their position. That's why they are rigid in nature. Next question. Why do solids have definite volume? Solids keep their definite volume because solids have certain volume because their atoms' positions are fixed. Why atoms' positions are actually fixed? Because they have strong molecular forces of attractions. Between one particle and another particle, the forces of attractions are very strong. Because of that forces of attraction, they are rigid. And when their force of attractions are strong, particles comes closer and they have very few interspaces. Gaps are very less. As a result, their volume we can't change by applying pressure. Why do solids have definite volume? Because between the atoms, the force of attractions are more. Empty spaces are less. Even you apply a pressure also, there will be no empty space, so that they are not compressibility almost negligible, we can say. That is the reason they have definite volume. Clear? And see the next question. Classify the following as amorphous or crystalline solids like polyurethane, naphthalene, benzoic acid, Teflon, potassium nitrate, cellophane, and polyvinyl chloride, fiberglass, copper. See, poly, a small technique I tell you. Wherever poly is there, you can name it as an amorphous, polyvinyl chloride. And Teflon also actually polymer. Next, fiberglass. These are amorphous. Here, polyurethane, Teflon also polymer, cellophane, this is also cellophane, polyvinyl chloride polymer, fiberglass. These are amorphous. You should keep in your mind. Crystalline solids are benzoic acid, potassium nitrate, copper. These are crystalline solids. What is the difference between amorphous? These examples you have to remember. What is the difference between amorphous solids and crystalline solids? Students, tell me. Amorphous solids means a short range order. Whatever the particles arrangement is there, that is only up to certain distance. But coming to the crystalline solids, particle arrangement long range order. Long range order we can see. That's the main difference. See the next question. Why is glass considered as a supercooled liquid? Why it is a supercooled liquid? Because in a glass means it is a solid. But why it is called as a supercooled liquid? Glass is an example of amorphous solid. But why we are calling as a liquid? Because amorphous solids have certain characteristics. What is that? The characteristics of amorphous solid is that whatever the glass, if you see for the old buildings, at the bottom part, thicker it will be. Bottom part, what is happening? Slightly thickness we can observe. Why actually bottom part will be thicker? Because old buildings, if you observe this nature we see, the sunlight falls, particles will heat up. Again, because of moon, it will be cooled down. Heating, cooling. Upon longer days, if it happens, then the particle slight movement we see from top to down, and the bottom part of the glass, this is a glass, for example, the down part of the glass, here it becomes thicker because of slight movement of the particles. This nature we call it as an, that is the reason we call it as super cool liquids. What is the reason, students? Because of slight movement. See here, this can be possible only if it has flown like a liquid, though very slowly, not like fast movement like a liquid, little slight movement we will observe. That's why super cool liquids. Next question. Refractive index of a solid is observed to have same value along all the directions. Comment on the nature of this solid. Would it show cleavage property? What is the meaning of this is amorphous solids, they have same physical properties in all the directions, because amorphous solids are isotropic in nature. Repeat. What is the nature, students? Isotropic in nature. What is the meaning of isotropic in nature? Similar properties in all directions. So based upon this, they are telling refractive index of a solid is same value. Same value in the sense it is amorphous only. What nature it will show? If you cut it, it don't show nice cut. It will break into pieces. See here. As a solid has same value of refractive index in all the directions. What is the meaning? That means it is isotropic in nature. Isotropic means those solids are amorphous solids. Amorphous solids not shown a clean cleavage. When we cut it, it will break up. When we cut it, it will break up into what? Pieces with irregular surfaces. Surfaces cleavage won't be clear. See the next question. Classify the following solids in different categories based upon the nature of intermolecular forces. See here, sodium sulfate is given. Sodium Na2SO4. It is ionic. And copper. Copper is a metal, so metallic. Benzene will be molecular. Urea will be molecular. Ammonia will be covalent. Correct. Water will be covalent. Zinc sulfide will be, you can say, zinc sulfide will be ionic. Diamond is in covalent. Rubidium is a metal, so rubidium is a metal, so metallic. Argon, it is molecular. Silicon carbide will be, covalent. So based upon that nature, one tabular column is there in NCERT. You have to read the tabular column, then it becomes easy for you. Ionic, metallic, which one is ionic? Na2SO4. Na2SO4 is, this is ionic, Na2SO4. Next, copper, see, metallic. It's missing. Metallic, copper. Metallic, copper. This is copper. Next, benzene is molecular, correct? Urea is molecular, correct? And ammonia is, yes, ammonia, actually NH3, inside NH3 it is covalent, but NH3 involves in hydrogen bonding between two NH3 molecules, correct? It is molecular. And, water also molecular, right? Because within the water, it is covalent bonded, but between two water molecules, we are talking here between, right? So between the two, it is hydrogen bonding. Zinc sulfide, Zn2 plus S minus 2, ionic. Diamond is covalent. Rubidium is metal, so metallic. Argon is molecular. Silicon carbide is covalent. Understanding? Is it clear? See the next one. Solid A is very hard electrical insulator as well as in solid state as well as in molten state, and melts at extremely high temperature. See, some solid is insulator, fine, it is insulator, but they were telling that in molten state also insulator. Solid state only insulator means ionic. But if it is ionic means in molten state, free ions will be there. It will show the conductivity. But here it is molten in solid state as well as in ionic state, means there will be no free ions. Then it is a covalent solid, which is also known as network solid. One is covalent solid. What is the other name, students? It is also known as network solid. See the next question. Why are ionic solids conducting in the molten state and not in the solid state? Because in a solid state, particles' positions are fixed. They can't move freely. But in a molten state, free ions will be available. See here, in the ionic solids, electrical conductivity is because of what, students? It is because of movement of ions. Ionic mobility in a solid state is almost negligible. You can see in a solids it will be almost negligible ionic mobility because there is no free ions. They are non-conducting in nature in solid state. Understanding, they are not conducting in nature in solid state. But upon melting, then ions will be created because of those ions. They shows the conducting nature. So normally in solid states, they are not good conductors. They act as an insulator, but in a molten state, due to the presence of free ions, they shows the conductivity. See the next question. What type of solids are electrical conductors, malleable and ductile in nature? If you see, metallic solids are electrical conductors because of the presence of free electrons. They are malleable and they are ductile. Malleable and ductile means we can convert them into thin sheets and required shapes, and in the form of big wires we can convert. Only with the metals it is possible. See the next question. Give the significance of a lattice point. Lattice point means representation of atoms in the form of a point. For example, if you see the space filling model, it will be like this. Here one sphere, it is one sphere, space filling model, 4 atoms like this. Again, another 4 we keep on the top. Total 8 it will be. But that 8, it is difficult to write that 8. That's why what we do is just those 8, here 4, on top another 4, same we are keeping. It is very difficult. So what we can do, that sphere we can write in the form of a dot. That point we call it as lattice point. Understanding? So this is a lattice point. What do you mean by lattice point? Lattice points denotes the position. Lattice points, what it will denote? Lattice points will denote the position of a particular constituents in the crystal system. In that crystal lattice, it may be atom, it may be it may be a molecule. The arrangement of these lattice points in the spaces is responsible for a particular shape. Because of this arrangement, that particular representation of a point, I mean that atom in the form of a point, we call it as a lattice point. Because of this lattice point, that particular one shape, that unit cell will get the shape. Next question. Name the parameters that characterize a unit cell. Actually, if you see the cube, how the cube structure will be? This is a cube. Now, here I'm having here one atom, here one, here one, here one, like that corner, face, centers, depending on that. I want to tell you that this length will be A, This will be edge length will be B. This edge length will be C. Total 3 edge lengths will be length, width into height. Now, A, B, C are the actual distances. Now, let us take alpha, beta, gamma are the angles. Between A and B, technique. Between A and B, don't take these two, take gamma angle. Between A and C, simple techniques I'll tell you. AC, this is beta. AC, this will be beta. Between C and B and C, don't take these two, take alpha. So alpha, beta, gamma, A, B, C. There are total 3 distances are possible. Total 6 parameters are needed. See here, 3 edges A, B, C and total 6 parameter angles alpha, beta, gamma. Total 6 angles are needed. So angles you no need to by heart. Just you simply write A, B, C, alpha, beta, gamma. Between these two, they're asking alpha. Between these two, they're asking gamma. Like that, you can solve the question. Okay. And see the next question. Question number 12. Distinguish between hexagonal and monoclinic unit cell and face-centered and end-centered unit cell. What do you mean by hexagonal unit cell? Hexagonal unit cell means A is equal to B is not equal to C. And because I told you one trick in the classroom. If you observe, otherwise you go through the NCERT, you can observe that. But in NCERT, the pattern will be different. You check it out. CT, OTH, MT. In this case, A is equal to B is equal to C. A is equal to B not equal to C. A is not equal to B is not equal to C. Same thing you have to repeat. A is equal to B is equal to C. A is equal to B not equal to same. This 3 one more time you have to repeat. All the 3 are not equal. Same trigonal also, all the 3 are not equal. So here I want to tell you hexagonal unit cell A is equal to B not equal to C. And their angles are alpha, beta is equal to 90 degree and gamma is equal to 120. This is hexagonal unit cell. And monoclinic, all the 3 are not equal. Alpha and gamma is equal to 90. Beta is not equal to 90 degree. It is very, very important. You have to learn this entire thing. They may ask you anything. In this first 3 cases, alpha, beta, gamma is equal to 90. C, T, O also. Okay, triclinic, all the 3 are different. Alpha, beta, gamma not equal to 90. So it is important you have to learn the angles and actual distances. Now, you can see here, hexagonal you learned and monoclinic you learned. Now coming to the face center. Face center means atoms are present at the corners. How many corners, students? Atoms are present at the corners and face centers. And end-centered unit cell means atoms are present at corners and any opposite to face center. Let us see how to find that corner and face center. I will teach you now. Are you ready? Are you ready? See here. This is the unit cell. Here where the atoms are present in the case of face FCC. Corner. This is one corner. Corner. Now this top face center, left, right face center, left face center, down face center, front face. This is front face center. Again, see back face I'm drawing. Back face center. In your room, left face. In where you are sitting, you see. Your left side one wall will be there. Right side one wall will be there. Back side one wall. Front side one wall. Top one roof. Down one bottom. So left side wall center. right side wall center, back side wall center, front side wall center, roof center, down center. So total 8 corners and 6 face center. In case of end-centered unit cell, atoms are present only at the, you can see atoms are present only at the corners and opposite any 2 face centers. I'll show you here. Corner, 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 corners. All 8 corners it will be present and any opposite 2 face centers. One here, one here. Any 2. Then it will be end-centered unit cell. See the next one. Explain how many portions of atom located at a corner. I mean, if an atom is at corner, suppose this is an cube, atom at this corner is in sharing with 8 other unit cells. In a small cube, if you consider, one corner atom will be in a sharing with 8 other unit cells in it. So corner contribution is 1 by 8. But if it is present at a body center of the cube, then it is not in sharing with any other unit cell. So its contribution is 100%. 100% means 100 divided by 100, that is 1. So when an atom is at corner, you have to give contribution. How much, students? 1 by 8. 1 by 8. If atom at corner, you have to give 1 by 8 contribution. If it is face center, 1 by 2. If it is body center, you have to give 1. If it is at edge center, we have to give 1 by 4. Is it clear? In the next session, I will teach you remaining questions from Intext Questions of Solid State chapter. I hope you understand this session. See you in next session. Have a nice day. Bye, all of you.